This SOHCAHTOA, we are going to use it to solve certain problems that are related with a triangle. Here I'm going to write a triangle. But first of all, you need to know when to use this, and if the triangle that you're using has a right angle, I mean like this, right and right, you're going to use SOHCAHTOA. But this is in the only case that you can use it. Like for example, if you have a triangle uh, like this, you cannot use SOHCAHTOA because this triangle does not has a right angle. Only when it has a right angle, like in this case. The first problem that we're going to have today is a problem that says a plane travels an horizontal distance of 3,500 miles, which will be like this. The plane is traveling in this distance, and here are the 3,500 miles, and while gaining a height of 1,000 miles, which means that this airplane is at a height of 1,000 miles. And specifically, this problem is asking us to determine the angle of elevation from the starting point, which means that we need to write a line like this, and we need to the problem is asking us to calculate this specific angle. First of all, we need to know that in this problem, this right angle always is going to be 90. So we already have a result in this little problem. So we need to have identified our sides. Like this is the opposite side, this is the adjacent side, and this is the hypotenuse. So here are the operations of sine and of cosine and of tangent. In this case, we're going to use this operation that is sine, that is opposite over the hypotenuse. We want to obtain c, so we're going to write the sine of 90, which is this angle, will be equal to opposite over hypotenuse, and the opposite is at 1000, so we're going to write here 1000, and the hypotenuse we don't know it, so we're going to write just the h. So we want to know c, so we're going to pass h to the other side and 90 to this side, which will be like this. 90 is multiplying, so it's going to pass dividing like this. The h is going to keep here, and it's going to be 1000 over 90. So we already know that 1000 divided by 90 is 11.11, and the three sides of a triangle, like the three sides of a triangle added, need to give 180. Like these three sides, the angles, if you add them, need to be 180. So here is 90 plus 11.11, which will be 101.11. So if you do 180 minus 101.11, the result of 180 minus 101.11 would be 78.89. So they didn't ask us to know this data, but we can know that this other side that is resting is 78.89. Here, as we can see, we are in the second problem. It says on a map, point A is 2.5 centimeters to the west of point B. This referring that, for example, point B is here, and point A is 2.5 centimeters to the west. So up to here, there will be 2.5 centimeters, and this will be point B, and this will be point A. And it says that there is a third point that is C, and it's located above these two, like referring to that is here, and is 3.5 centimeters from point B and 4.2 centimeters from point A. This meaning that it's above. So here there will be 4.2 centimeters, and here will be point C, and here, for example, there will be the 3.5 centimeters that is from point B to C, and this is the example. This problem asks us to determine the angle to point C from point A. This referring to from point C to point A, so they are asking us for this angle. And the question is, how are we going to get this angle? But there is a formula that is this one. I'm going to write it. Is a squared b squared plus c squared minus 2 times b times c cos a. And we first need to substitute this formula according to the values that we have here in the triangle. First, we need to know that the side that is in front of angle A is going to be the A mini, and the side that is in front of B is going to be another B mini, and the side that is in front of C is going to be another C but mini. Now that you just need to substitute the values as I did here with 3.5, 4.2 and 2.5 according to the values that you have in the triangle. Here what I did is very simple because I just substituted the values, and here I did 4.2 squared, 2.5 squared, and this thing of minus 2, I put it all together. And here I also did 3.5 squared, that it was 12.5, and these two values, the 17.64 and the 6.3504, I add them and it gave me 23.9904, and I put all the values like they were first. What I did next to that was to pass all the values to this side, to the left side, and left the 23 here alone. And next to that I left in the left side 21 cos x alone, and I pass all the numbers to the right side. Next to that I did the rest of the 23 minus the 12, and it gave me 11.7404, and this side I left it like it was. And then I try to pass the 21 to the other side, so it would be 11.7404 divided by the 21, because the 21 was multiplying, so it passed dividing, and the result of this was 0.5590. Next to this, it was time to pass the quotient to the other side, so it passed as cos with the minus 1, and in the other side it was the 0.5590, and we need to do this in the calculator, the cos minus 1 and the 0.5590, and the final result was 56.63, and that is the result of the angle. So we can know that this angle is 56.63 degrees, and this is the final result. And I can say that thank you for your attention with these problems. They were a little bit tricky, but if you find the form to do it, you can do it in a good form.